Sorry for my part one screw up there at the end. So we're going to continue looking at neuron physiology. So here we have our multipolar neuron, and I'm going to draw another multipolar neuron down here. And again, this area right here is the synaptic cleft. All right. So we have these dendrites, which are sensing or feeling processes, and something is going to bind onto a dendrite right here, and it's going to cause an upset in the polarized nature or resting nature of the plasma membrane of the neuron. So at rest, typically the neural lemma or plasma membrane of a nerve cell, a cell is negative on the inside, more negative on the inside, and more positive on the outside. But when some sort of stimulus comes over here and attaches or stimulates an area of a dendrite, this polarized nature is going to change. It's going to become depolarized. And how that happens is we have the ion sodium, Na+, that's actually going to start rushing into the cell, and it's going to cause a localized depolarization of the plasma membrane. So now the plasma membrane is going to become positive on the inside and positive on the outside. And this depolarization is going to occur only at this area until it reaches a certain threshold or set point. And typically it goes from negative 70 millivolts on the inside of the cell to positive 30 millivolts, because we have this positive sodium charge rushing into the cell. Once it reaches this magic number of positive 30 millivolts, then an action potential fires. Then the entire plasma membrane or neural lemma becomes depolarized. What happens is that now we have, this is, right here was a ligand stimulated channel that was allowing sodium into the cell. So some sort of substance had to come over, bind onto these channels for sodium to be able to come in. But now, because we reach this positive 30 millivolts, voltage-gated channels open up of sodium, and now sodium can rush in along the entire length of the plasma membrane, and that's going to fire down the axon until it reaches the axon terminals. So in this green right here, I'm showing an action potential that is going to fire down the entire length of the axon, and it's going to reach the end here at the axon terminal. So then what happens? Well, this nerve impulse needs to get sent to whatever this postsynaptic cell is. In this case, it's a multipolar neuron. Well, we can't have this electrical current being sent from this cell to this cell. So now we're going to be relying on chemical messengers. So at the axon terminal, what exists are little packages of what are called neurotransmitters. When we get to the end of the neuron, we talked about in chapter 6, we have these calcium voltage-gated calcium gates that open up. Calcium comes into the axon terminal, and they stimulate the release of these neurotransmitters into the synaptic cleft. And you have these neurotransmitters that are going to move down their concentration gradient. They are going to bind onto the postsynaptic cell, and if you remember, this is what happened up here, they're going to cause the same event to occur. A localized depolarization is going to occur where sodium is going to rush into the cell, cause an upset, and then the entire thing is going to happen again. And that is neuron physiology.